Hi guys, welcome to today's video on drying, grading and packaging of sugar. If you are new to my YouTube channel, I am Rebecca, the food scientist. My channel focuses on chemical composition of food products, processing of food products, and laboratory analysis done in food industries. If you are interested to know how sugar is dried, graded and packaged in sugar industry, be my guest. Sugar crystals from batch centrifuge has moisture content and temperature of around 0.5% and 70 degrees Celsius respectively. These parameters have to be reduced to 0.05% and 30 degrees Celsius. Reasons for drying are: 1. Prevent formation of lumps in packaged sugar. 2. Minimize growth of microorganisms. Remember, microorganisms can deteriorate sugar quality through fermentation process. 3 is to improve handling characteristics of sugar. Remember, dry sugar flow freely, hence easy to package. The reasons for cooling are: 1. Hot sugar is hygroscopic in nature. If it's bagged directly, it absorbs moisture from atmosphere during cooling and form lumps. 2. High temperature accelerate caramelization of sugar, leading to darkening of sugar color. Finally, high temperature also accelerates the growth of microorganisms. Drying and cooling can be done by various means, that's cooling towers, rotary dryers, and fluidized bed hoppers. Most companies prefer using rotary dryers, while others prefer using hoppers. So today I'm only going to cover rotary dryer and hopper. Hoppers are generally made of galvanized trays. They are normally 1.2 to 2.0 meters wide and 20 to 30 meters long. A bed of wet sugar from the batch centrifuge is dropped to hopper 1. This sugar from hopper 1 is dropped to hopper 2, where it's fluidized by a stream of hot air to remove moisture. Hot and dry sugar is then dropped to hopper 3, where it's fluidized again by a stream of cold air to cool. Wheels of the hoppers enable the grasshopper movement to enable sugar to move efficiently without clumping together. The advantages of hoppers over the other types of dryers are: 1. Does not cause any damage to sugar crystal. 2. There is no erosion. And lastly, the luster of sugar crystals is maintained. Let's cover the horizontal rotary sugar dryer. This device comprises of a horizontal rotating cylindrical drum running on steel roller. The drum is driven by gear and chain sprocket. The roller runs on 2 path rings fastened at outside of the drum. The inner side surface of the drum is fitted with lifters that is filled with sugar. Lift it and pour it out as the drum rotates. The drum is sloped towards the discharge end, and sugar moves progressively by means of lifts and falls towards the discharge end. Continuous air blowing is arranged axially through the drum, passing through falling curtain of sugar to achieve drying. Remember, this air is dry and hot. After drying, cold air is also passed through sugar crystals to cool them. For efficient drying, the diameter of the drum should range between 1.8 to 2.4 meters. Diameter greater than 2.4 can result in partial damage of the sugar crystals. As the drum moves, the sugar is allowed to fall down several times, resulting to better drying, exchange of heat and lesser sugar crystals damage. Let's cover the next stage of sugar handling. The obtained cool and dry sugar consists of heterogeneous crystals and needs to be well graded before it is packaged. Sugar from dryer is transported to grader by bucket elevator 1. Sugar from the elevator buckets drops at the top deck of sugar grader through sugar distributor. The distributor has rotating shaft with strips which distribute sugar crystals evenly on top deck. Grader has 3 screens of different mesh size which separate large crystals and very small crystals from commercial sugar that has recommended size. These screens are fixed in frames and arranged sequentially from the largest to smallest in order to facilitate grading of sugar. The frames vibrate at a very high speed by means of eccentric and are bed-driven by a motor. The vibrating movement reduces choking of screens and enables faster flow of sugar crystals. Sugar crystals with the recommended size is conveyed to bins by the bucket elevator 2, while conglomerates and small crystals are taken to dry seed mixer. Sugar stays in bins for some time before it's packaged in order to cool and also remove any moisture droplets released by sugar crystals. Sugar from the bin is packaged in clean and new jute bags or nylon papers by the use of autoscales. The bags may be lined with polyethylene film. The mouth of each bag is either machine stitched or rolled over and hand stitched, while nylon papers are sealed by machine. Packaged sugar is stored in godown before it's sold. Each packaging material should have the following information. Number 1, company address, batch number, type of sugar at the time of packaging, if it's brown sugar or white sugar, net weight of sugar, expiry date, and nutritional content. Below are factors to consider while storing sugar in order to maintain its quality. Number 1, temperature and relative humidity should not exceed 28 degrees Celsius and 50% respectively. Next, stacking of sugar bags in godown has to be restricted to 25 bags to avoid sun heat. Sugar should be stored separately from other products to avoid picking up of moisture and odors. In humid areas, air conditioner has to be used to control relative humidity and temperature changes. Finally, sugar has to be conditioned first before packaging. Let's see how sugar dust, conglomerates, and small sugar crystals are handled after they are removed from commercial sugar. Sugar dust from the dryers, grader, and elevators is trapped by the fans and blown to sweet water tank where it's mixed with water. Sugar dust in sugar house has to be collected because of the following reasons. Number 1, to avoid air pollution. Number 2, reduce risk of fire explosion. Number 3, prevent sucrose loss. Remember, this sugar dust is majorly made up of sucrose. Number 4 is to avoid health hazard and ensure good hygiene. Finally, is to improve product quality. Conglomerates, small sugar crystals, and sugar deposited on the ground is taken to dry seed mixer to be mixed with hot water. Hot water loosen conglomerates and lubricate sugar crystals for easy pumping to remelt tank. C magma, excess B magma, sweet water, and sugar from dry seed mixer is pumped to remelt tank to be remelted. Remember, the solution from remelted tank is taken to pan A to raise the purity of syrup. That's the end for drying, grading, and packaging. Below is the summary of pan boiling. Syrup from the evaporators is mixed with melt and B sugar to make A macecute. A macecute is centrifuged to obtain A molasses and A sugar. A sugar is dried and packaged, while A molasses has around 70% purity, so is mixed with slurry in pan B to make B macecute. B macecute is centrifuged to obtain B molasses and B sugar. B sugar is used as initiator of crystallization in pan A. B molasses has around 50% purity, so it's mixed with slurry in pan C to make C macecute. C macecute is centrifuged to obtain final molasses as byproduct and C sugar. Thank you very much for watching my videos. This is the last stage of sugarcane processing, though there are other sections that are related to sugarcane processing like sugar losses, effluent treatment, water treatment, and power generation using biogas. I'll cover these sections in the next videos, so stay tuned.